All right, if you're getting ready for your GCSE Physics exam, you have come to the exact right place. We're going to nail a really key part of the atomic structure topic. That's nuclear fission and fusion. Let's get you sorted for that exam. So here's how we're going to break it all down for you. We've got 5 simple sections to make sure you get everything you need. We'll start with fission, then get into how chain reactions work. After that, we'll jump over to fusion, compare the two of them side by side, and then we'll wrap it all up with a super quick recap of everything you need to remember. Sound good? Let's get into it. Okay, so first up, what is nuclear fission? Well, at its heart, it's all about splitting things. But we're not just splitting logs. We're splitting things on a tiny, tiny atomic scale. It's kind of like we're cracking a secret code hidden inside the nucleus to unlock this just incredible amount of energy. Now, pay attention to this bit because for your exam, this is the definition you absolutely need to know. Nuclear fission is simply the splitting of a large and unstable nucleus. And those key words are, well, key. Large and unstable. Think of the real heavyweights of the periodic table, like uranium or plutonium. They're just naturally unstable, kind of ready to split apart. So how does this actually get started? It doesn't just happen on its own, right? You need a trigger. A big, unstable nucleus, let's say uranium-235, it has to catch or absorb a slow-moving neutron. That's the first critical step. Once it absorbs that neutron, the whole nucleus gets super wobbly and just splits. It breaks into 2 smaller nuclei. But, and this is the really important part for what comes next, it also lets go of a ton of energy, some gamma rays, and crucially, 2 or 3 more neutrons. And you're going to want to remember those neutrons because they're the stars of the next part of our show. And that right there leads us perfectly into our next topic, the chain reaction. See, those neutrons we just talked about, the ones that get released, they don't just fly off into space. Oh no, they go on to cause even more fissions. Yeah, this visual breaks it down perfectly. Just look at what's happening. It all kicks off with one single neutron hitting a nucleus. The nucleus splits, bang. It releases energy, and you can see here 3 new neutrons. Now, just follow those arrows. Each one of those new neutrons can go on to hit another nucleus, causing 3 more splits. And the whole thing just snowballs, One split becomes 3, which becomes 9 and 27. It just escalates incredibly quickly. And don't forget, with every single one of those splits, a huge burst of energy is released. So as that chain reaction gets bigger and bigger, the amount of energy being released just skyrockets. It grows exponentially. And that right there is the basic idea behind how nuclear power works. Okay, so this all comes down to one really important idea: control. Inside a nuclear power plant, they control this chain reaction really, really carefully. They use things called control rods to basically soak up some of those extra neutrons. This makes sure that on average, only 1 neutron from each split goes on to cause the next split. It keeps the whole thing running at a nice, steady, manageable pace. But what if you don't control it? What if you just let it run wild? Well, then you get an uncontrolled chain reaction. And that is the terrifying principle behind a nuclear weapon, where all of that energy is released in one massive, instantaneous explosion. Right, so that's fission all wrapped up. Now let's flip the coin and look at its opposite, nuclear fusion. If fission is all about splitting things apart, you can probably guess that fusion is all about joining things together. And this process, this is literally what powers the entire universe. And just like before, here's that key exam definition you'll want to remember. Nuclear fusion is the process of joining 2 light nuclei to form a heavier one. Simple as that. So, instead of breaking up a massive atom like uranium, we're taking really light things, like different types of hydrogen, and squishing them together. So where does all the energy in fusion come from? This part is actually pretty mind-blowing. See, when those 2 little nuclei join together, the new, heavier nucleus that's created, well, it actually weighs a tiny, tiny bit less than the 2 original ones did added together. So where did that missing mass go? It didn't just vanish. It's been converted directly into a huge amount of energy. And the best example of this in action? Just look up. It's happening right now in our sun. Inside stars, fusion is constantly happening. The incredible outward push of energy from all that fusion perfectly balances the massive inward pull of gravity trying to crush the star. It's this perfect balancing act that lets stars like our sun shine for billions and billions of years, giving us all the light and heat we need for life here on Earth. Okay, so you've got the basics of fission And you've got the basics of fusion. Now, a really common thing they'll ask you in an exam is to compare the two. So let's do exactly that. It's time for our fission versus fusion showdown. Okay, this table right here, this is your secret weapon for revision. Screenshot it, memorize it, whatever you need to do. Let's just quickly run through it. First up, the process. Fission is splitting. Fusion is joining. Easy. What about the fuel? Fission needs big, heavy stuff like uranium. Fusion needs light things like hydrogen. And the products? Well, fission gives you 2 smaller nuclei plus those extra neutrons. Fusion just gives you 1 heavier nucleus and energy. And finally, and this is a big one, the reaction type. Remember, fission is the one that can cause a chain reaction. Fusion doesn't work like that. Phew. Okay, we have gone through a lot of information there. So let's just take a moment to boil it all down with a final recap. These are the absolute non-negotiable points you have got to remember for your exam. All right, you ready? Let's drill these in. Number 1, fission, splits. Number 2, fusion, joins. Got it? Number 3, a chain reaction only happens with fission. Number 4, both of them release huge amounts of energy. Number 5, the one we use today in power plants, is fission. And finally, number 6, the one that powers the stars, is fusion. If you can remember those 6 things, you are absolutely golden. So let's finish up with a little food for thought. We've gotten really good at controlling fission, right? We've used it to power our world for decades. The next massive challenge for science and engineering is to do the same thing, but with fusion, to basically build a mini star right here on Earth. I mean, if we can crack that, we're talking about clean, safe, almost limitless energy. So fission is our present, for sure. But could fusion be our future? Well, that's exactly what thousands of scientists are working around the clock to figure out. Anyway, that's it for me. Best of luck with all your revision.